Hello, astronomy and astrophysics enthusiasts. After qualifying my INAT exam, I appeared for interview at IUCAA. The interviews were of two rounds. In this video, I'm going to share my experience of the first round of interview. If you're preparing for integrated PhD or PhD at IUCAA or any other institute in India, or even if you just want to challenge yourself with interview level questions, watch this video till end. So without any further ado, let's get started. The first round of my interview at IUCAA was set to be held on 24th month. The reporting time was 9 o'clock in the morning, but I reached there at 12 o'clock. Actually, I had an interview at ICTS before that day. So from Bangalore, I had to travel to Pune, and there I reached at around 11 and then reached the campus at 12. So it was really tiring that day, and I was really feeling like what will happen, how will I perform in the drill. I reported, I filled the form, attendance sheet, and then I was waiting in the waiting lounge. And my turn for the interview came at around 3 in the evening. When I entered the room, there were five professors. The panel was of 5 members, and they asked me to relax, take deep breaths, and sit down. Actually, I sat down there, and then to ease my nerves, they started asking some introductory questions. Who am I? What am I doing in India? Where am I from? So when I said that I'm actually from Nepal, they were amazed. A boy from Nepal has done this, and I mean, it was really impressive, and I was feeling too good, and it really calmed my nerve. So interview at any place will be like this only. The professor will ask you to come in, and then they will ask some personal questions, something you are comfortable sharing, and there you can use that questions to tell about yourself and ease the nerve, drop the tension in the room, and start feeling comfortable. So you can use those questions for your benefit. From there, after 2-3 small questions, one professor asked me, have you learned electricity and magnetism in your school, college? I said, yeah, it's like a mandatory course in every semester. Every college course, right? So we had actually learned it in second semester. So he started with a question like this. Here you can see on the board. There's the first question. He asked, if I have a plate, circular plate, as you can see here, the circular plate, and I make a small hole at the center, and there are charges on the rim, on outer circumference of this plate, like this, distributed uniformly all around its rim, and then I drop another charge through this hole. So he gave me this setup, and then asked me what will happen to the plate once I drop this charge. The plate is free to move. It is held in place at this location by some string, maybe some string attached to it, and the plate is stable here. Once I drop this charge, this positive charge, what will happen to the disk as a whole? So I answered, since the charge is dropping, it will create an effect of electric current, and from there it will have some magnetic field. You can check the answer yourself. You can try to answer this question, and there you can have experience of this interview for yourself as well. So this was the question, and this was the setup for the first question. After that, he asked, after I answered, the plate will start revolving, rotating about its axis. So he asked, can you write some equation which will explain it? So I asked him to clarify, are you asking some Maxwell equation that will be related to this? So he said, yeah, actually that. So I wrote Maxwell equation of that curl of electric field once. So he said, yeah, fine, let's move on to the next question. So from after this question, actually this question was also to ease my nerve. It was just something ice breaking question. From there, he passed down the baton to another professor in the team, and he asked me, so what are your good subjects? What are the things you enjoy learning in your college and out of your college as well? So I told him I really enjoy mathematical physics. This is my strongest suit, and then classical mechanics and quantum mechanics are my interest, and I'm actually interested in gravity as well. I mean, as a research career perspectives, really interested in gravity to learn about it and how gravity works in Einstein relativity. So I told about this. And then he asked, he said, okay, so you like classical mechanics, so I'll give you a question. And this is the question that he gave me, the second one. As you can see here, he's told me there is an inclined plane. This is the inclined plane, and it has an angle theta, I mean with the horizontal. So if I take a spherical ball at the highest point and then leave it, what will happen to the ball? I didn't get the question at the first. I was like, what do you mean? The ball is dropped, so it will just come down at the bottom. He said, can you make some physical scenarios? What are the possibilities? From there it clicked to my mind. Okay, yeah, so he's asking about what different scenarios can there be. Like the inclined plane can be frictionless, it can have friction. So if it is frictionless, there will be no force, frictional force, that will provide torque to the spherical particle, this spherical ball. So it won't roll down, it will slide down. So if there is friction, it will roll because the friction will provide torque to rotate the ball. So I answered this, and he was, I mean, I felt like he's really impressed. I was feeling so happy within myself that I answered it correctly. So from there, he said, okay, so let's consider it is frictionless. So what will happen? How much time will it take to reach that bottom for the ball? Okay, so I said, yeah, I can calculate that with the angles and then decomposing the gravitational attraction, I mean g in direction perpendicular to the plane and then in direction of the plane. So from there I calculated the value and it came out some number. You can try it yourself again, I'm saying. These are the questions you can try yourself and see how well you could have performed in the interview. And this is like a real check as well. You don't know the question, I'm providing you try to answer yourself, and if you get like 3, I mean out of 4, if you can get 3 questions right, I think you're good to go. You can easily qualify the interview. In the interview as well, that they don't look for the final answer, they will always look how you thinking, what you are what are the assumptions you're making, and how accurate are you with your assumptions. So these are the things they will check. You can try this yourself, try speaking out the answer as well, and you will be good to go. So then he just complicated the situation and gave me another scenario. He said, what if I attach a ramp of this shape, like a U shape, at the bottom of the inclined plane? What will happen to the ball now? So I answered, it will just come down to the bottom, and because there will be some kinetic energy, it won't be at rest at the bottom, so it will move up as well on the other side. And since here A looks smaller than h, the particle will just fly off of the ramp on the other side. So he said, yeah, that's really correct. So can you calculate how far will it reach and what time it will take to reach there? I calculated it on the board, I found the expression, and he seemed satisfied. He was really satisfied there. So he again passed the baton to another professor, and he seemed to be expert in mathematical physics. So he just asked me, so you said mathematical physics as well, right? So I'll ask you a mathematical question from linear algebra. Let's see how much do you know about linear algebra. So he came and asked me, he gave me 2 matrices actually, 2 square matrices of order n by n, as you can see in the question. And he said the corresponding elements of B, I mean matrix B, are smaller than the corresponding elements of A. Actually he meant if A is a matrix 1, 7, 2, 3, like this, a square matrix 2 by 2. In generalized case he asked for n by n, but here I'm just writing 2 by 2. And then matrix B is very small than A. Elements of matrix B, since matrix A has element 1 at position 1, 1, here it will be really small. Let's say 0.002. In the second element it has 0.337. Oh, sorry, it should be small, so 0.00, let's say 0.007, 0.0003, and then 10 raised to minus 4, like this. The corresponding elements of B are really small. This is for just for example. He didn't give me any element of the matrix. He just said A and B are matrices of order n by n, and both the elements of B are really small. Corresponding elements of B are really small than elements of A. And then he asked me, what will be the inverse of A plus B matrix if both A and B are invertible? Okay, so the only extra condition he gave me was A and B are both invertible. So what will be the inverse of A plus B? So the answer he was looking for was in the form of Taylor expansion and all. I just pointed out in that direction. So he said, yeah, you can do that. So can you compute it on the board and see what will be the form? He asked me to up to second order only. What will be the form of the inverse matrix up to second order, and from there I wrote it down. And then another professor was asking, can we actually do that for A plus B matrices, because A and B are not commutative, they are just any n by n matrix, and they can be or cannot be commutative as well. So I thought for some time, and I had no idea how to explain that question. He said, okay, you can carry on with the calculation. You can read it afterwards. So I said, yeah, okay, I will do that. Then another professor came up and he asked me, what will be the inverse matrix? What will be the eigenvalues of A plus B whole inverse? If lambda are the eigenvalues of A, matrix A, what will be the eigenvalues of A plus B inverse? I actually had no idea how to compute this and how to find any form of these eigenvalues. So I directly said, sir, I have no idea. After I came out of the interview room, I looked for it and I found that these are classic problems of perturbation theory, perturbation matrices and all. And if somebody has read about perturbation matrices, they will know how to find these eigenvalues and these inverses. I actually at that time I never had heard of perturbation matrices and had no idea how to compute these. So I just directly said them, actually, sir, I have no idea about this, but I can try, but I don't know if I will be correct or not. They said, okay, you can read it afterwards. Just now, this is enough for us. You already computed the inverse and up to second order, so I think this will be enough for us. Then again, the professors all looked at each other and said, should we let him go? Like, I felt that like they were discussing this, and then one professor said, okay, I'll ask the last question and then we can conclude the interview. So he came up to the board and gave me this scenario, the fourth question and the last for the first round of interview. He said, have you learned about classical Doppler shift? I said, about those change in wavelength and frequency of sound waves. He said, yeah, actually that. So I said, yeah, I've learned a lot. I've learned in my college and my school as well. So he said, okay, that's fine, that's really great, now you can try to solve this. So he gave me this scenario. He said, I think these questions have been asked in IIT exams as well, so these are not new type of question. Many of you have already done if you are preparing for IIT exam or TIFR GS paper. So the situation is like this: there is a bus A and then there is another bus B. They both are moving towards each other. Bus A is moving with 30 meter per second speed, and then bus B is moving with 50 meter per second. The bus A has a emitter, has a loudspeaker which is emitting sound waves, and then bus B has a reflector. The sound wave generated by A is getting reflected by the reflector at bus B, and the reflected wave is again detected by the detector at bus A. So the wave are coming from A, getting reflected by B, and then again detected by A. So he asked me, can you find the frequency that bus A will receive after reflection? It has emitted the frequency sound wave with frequency 300 Hz. What will be the frequency of the sound wave that it will receive after reflection from B? Actually, I had done these questions, so I was really comfortable and started solving it on the board. I found some numbers there, and he said, "Yeah, your intuitions were right. So numbers doesn't matter. Your forms and formulas were already good. So I think we are good to go now. You can, if you have any question for us, you can ask, or else you can leave now." I hope you like this video and got clarity on what type of question you can expect in your own interviews. Best of luck, stay tuned, and see you on the way of physics.